In this question, best time to buy and sell stock. We are given an array price and we are asked to maximize the profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. If we cannot make maximum profit from this transaction, we return 0. A brute force solution, as you can see here, iterates through all the price and the future price as a double for loop to calculate the maximum profit. But the problem with the brute force solution is that it has a time complexity O(n) squared and a space complexity O(1). How can we improve the efficiency here? One of the main problems in the brute force solution is that we repeat this first for loop many times. Actually, we only want to know what is the previous minimum price. How can we do that without repeating this for loop, the first one? That brings us to dynamic programming. Dynamic programming is to break down a main problem into smaller subproblems recursively and solve the subproblem first and leverage the optimal solution from the subproblem to solve the main problem. For example, what's the sum of 1 plus 2 up to 10 and plus 11? You solve the subproblem first, 1 plus 2 up to 10, and you memorize the answer 55 from previous computation. Then the answer to this question will be simply 55 plus 11 equals 66 without the redundancy to recompute the 1 plus 2 up to 10 part. With all the background knowledge introduced, we are now ready to write the code. Remember, we want to return the maximum profit, so we initialize it to 0. And now, the biggest problem in the brute force solution is that we have to recompute the previous minimum price. But instead of the need to recompute it, we initialize to the first element, and then we use dynamic programming to keep track of the previous minimum price. So our for loop is for j with the range 1 and the remaining price. And in each iteration, we want to keep track of the maximum profit. And at the end of this iteration, like this is a future transaction. Now, by the end of the day, we want to see if the previous minimum price can now be lower. If we can, it becomes a new previous minimum price. And this is dynamic programming. No need to recompute all the previous minimum prices. I pass from 0 through j. So, and then we return the maximum profit. And this is a solution we have. It reduced the time complexity from O(n) squared to O(n) because we only have a single for loop, and the same space complexity O(1), and let's test it. Submit, pending, charging, and accept it. 1032 milliseconds. It's pretty good. Thank you very much for watching.